Today we're starting 10.1, Introduction to Probability. When we're talking about probability, there's some definitions we have to know. First definition is what a trial is. When we're talking about probability, the trial is a systematic opportunity for an event to occur. In other words, rolling a die. Rolling a die is a trial. Next definition, experiment. An experiment is one or more trials. In other words, rolling a die 10 times. We have these two down. Next definition, sample space. A sample space is the set of all possible outcomes of an event. So if I roll a die, what are all the possible outcomes? 1, 2, 3, 4, 5, 6. Next one is an event. An event is an individual outcome or combination of outcomes, like rolling a 3 or rolling a 3 then a 5. Now for theoretical probability. Anyone know what theoretical means? Theory. What does that mean? It's something that you're using an educated guess. It's the mathematical probability. The theoretical probability, P of A, the probability of some event A, is the number of outcomes in event A divided by the total number of outcomes in the sample space. What's the theoretical probability of rolling a 2? So the probability of rolling a 2, it is not 2 out of 6. That is the number one mistake made. How many 2s are there on a die? There's 1 2. There's only one chance of rolling a 2. How many numbers are on a die? 6. So you have a 1 out of 6 chance of rolling a 2. Now 1 out of 6, we're going to take and divide it. 1 divided by 6, and I get 0.1667. And I'll just do 1.67, or 0.167. As a percent, what does this mean? 16.7% chance of rolling a 2. Just move the decimal over 2 places. So there's almost a 17% chance of rolling a 2. What's the percent chance of rolling a 3? Why is it the same? There's still only 1 3 on a die. So it's still 1 out of 6, which is 0.167, which is 16.7%. We'll get to that. 5 is going to be same thing. But how about, or what's the probability of rolling any number on a die? 1 out of 6. Every number has the same probability, theoretically. But what about an even number? The probability of rolling an even. How many even numbers are on a die? 3. How many numbers are on a die? 3 out of 6 as a decimals, 0.5, which as a percent means there's a 50% chance you're going to roll an even number.
You moved a decimal twice, you said?
Yep. What's the probability of rolling a prime number? First, you got to figure out what are the prime numbers on a die. Okay. 1 is not prime, nor is it composite. Prime means what? 1 and itself. So I have 2, 3, and 5. So 2, 3, and 5 is, again, 3 out of 6, which is 0.5, a 50% chance. 1 is nothing. No, 2, 3, and 5. Okay, here's what we're going to do. Don't try to perfectly draw the dartboard. We have the diameter of a dartboard is 17.75 inches. The bullseye has a diameter of 1 inch. What's the probability of a dart hitting the bullseye? Just write this down. Just draw a general circle for the dartboard, and then just draw the bullseye. A dartboard is a circle. If I throw a dart, it could land anywhere in here, right? What is anywhere in here? What would we call this? Inside of the circle. What's the inside of the circle called? Area. How do I find the area of a circle? Pi r squared. So if we're talking about the dartboard, the whole entire dartboard, pi means 3.14. How do I find the radius? It's half of the diameter, and that's the diameter. The whole diameter is 17.75. So I need to divide it by 2. I need to cut the 17.75 in half. 8.875. Now I just use the calculator, take that number, square it, times 3.14. So the dartboard has an area of 247.3 square inches. That's the whole entire dartboard. Now we're talking about the bullseye. And the bullseye is right here. How big is that bullseye? The diameter is only 1 inch. So let's find the area of the bullseye. 3.14. What's the radius? 0.5. It's half of my inch squared. So 3.14 times 0.5 squared. And I get 0.8 inches squared. So it's not even in an inch squared. I have this area and I have this area. So what's the probability of a bullseye? How do I find probability?
Well, you got to divide that by that.
What's that?
On the top and the bottom.
Okay, I have to divide the top and bottom. What goes on the top? What's this talking about? The whole entire thing. So that's the whole entire sample space that goes on the bottom. And on the top needs to go 0.8. I'm going to take 0.8 divided by 247.3. This will tell me the theoretical probability. 0.003, which as a percent means not 3%, 0.3%. Theoretically, you have less than a 1% chance of throwing a dart in the bullseye. Can you throw the dart in the bullseye? Yes, but theoretically, everything has the same chance. Theoretically, there's a 0.3% chance of throwing a bullseye. theoretically and actually are two different things. At lunch, you can pick a salad, a burger, or a pizza. To drink, you can choose milk, water, or pop. We're going to find the probability of choosing a burger and pop. So for lunch, I can have a salad, a burger, or some pizza. Now, if I pick a salad, what can I have to drink? Milk, water, or pop. How about if I pick a burger? Milk, water, or pop. For the pizza, milk, water, and pop. I put them out of order. How many different combinations could I pick for lunch? How many different possibilities? 9. I have 9 possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the faster way to do this? Why 3 times 3? I have 3 choices for lunch. I have 3 choices for drink, which gives me 9. How about if I said, all right, you have a salad, a burger, pizza, milk, water, pop, but you either get cookie or chips. How many would there be? How many different possibilities? There are 3 choices for your entree, 3 choices for your drink, 2 choices for the add-on. There are 18. If I put it over here, this has 2 choices, 2 choices, 2 choices, all the way through. How many do I have? 18. I don't need to draw this. Now, what's the chances of picking a burger and pop to eat? All right, here's the burger and the pop. I have 1 chance to pick it out of 9 possibilities. 1 divided by 9. This one you should know. This one's a special one. 1/9, 0.111111111. What's 2/9 going to be? 2, 2, 2, 2, 2. What's 3/9? 0.333333. But what other decimal, or what other fraction is 0.33333? What's 1/3? Why is 1/3 the same thing as 3/9? 3/9 means 1/3. So as a percent, 11.1%. You move it over 2 places always. The fundamental counting principle. I'll throw this up there. If there are m ways that one event can occur and n ways that another event can occur, there are m times n ways that both events can occur. This is what you just did for that problem. There was 3 choices for lunch, 3 choices for drinks. 3 times 3 gave me 9. That's all that this means. You're choosing a password for your phone. It has to be 4 numbers or letters. You don't want to use a 0 or an O because you don't want to mix them up. How many possible passwords are there for you to choose for your phone? How many possibilities do I have for the number aspect? I have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm not going to pick 0. How many possibilities do I have for the letters? 25. There's 26 letters. I don't want 0. There's a total possibility, or 34 different possibilities. Now, using the counting principle, how many possibilities do I have for the first combination piece? I have 34 possibilities. I could pick any number or any letter. For the second piece of my combination, how many possibilities do I have? 34. It's the same thing. How about for the third piece? 34. And how about the fourth piece? Same thing. There are 34 choices for each part of your combination. What do I have to do with these numbers? If I have an event that occurs in n way or m ways and another event n ways, I just multiply them. So what do I do here? Times them all. So it's 34 times 34 times 34 times 34. The faster way to do this is 34 to the fourth power. 1, 3, 3, 6, 3, 3, 6. There are 1,336,336 different passwords you could have picked. We're correct. Even, how about if I added a fifth number? And say your combination now is 5. Times it by another 34. I'm up to 45 million choices. Yeah, you would never pick it. Do you understand the probability and the counting principle?
Yeah, so that would just be the answer, you know.
That's it. Let's see.